Okay, here is a problem that is very similar to one that will be on our exam tomorrow. It reads, Franklin read 120 pages this week. Last week, he read 40 pages more than this week. Write an expression to find how many pages Franklin has read in all. And again, I really like to decode these first and separate out all the parts and then rewrite it as one solid expression. So we know that this week he read 120 pages. So I could write that as this week he read 120 pages. It then says last week he read 40 pages more than this week. Well, if this week it's 120, then it would be 120 plus 40 pages more. Okay? Now to write how many he read in all, if we want to write this algebraically, we try to be as efficient as possible. So I could substitute that 120 for a variable if I wanted, and because we're reading, maybe I just say that it is a book, or maybe I should do P for pages. How about that? So we're going to do P for pages, and when we talk about pages, I'm going to substitute that 120, and because I'm talking about this week and last week, there was at least 120 read both weeks, I'm going to say 2 times P, or 2 times 120 plus 40. And then I have an algebraic expression. I'm using a variable in there. I can leave it like such. I can also keep it as a numeric expression. And because I have all that information there, I could say 120 times 2 plus 40. So this is also written algebraically in the fact that we are trying to be efficient, because I know if I wasn't trying to be efficient, I could say 120 plus 120. This week 120, then last week 120 plus 40, and I would still come up with the same answer. However, this is an efficient numeric equation. Remember, when there's nothing between the parentheses and a number, it becomes multiplication. And this would be an algebraic equation. I've substituted the variable letter P to represent the value of 120. Okay, so either would be acceptable. We do want to work on efficiency though, so these are what I'm looking for. Let me show you a question that is very similar to one that will be on the test. And if I were to say that Taylor has 20 pencils. Okay, Taylor has 20 pencils, and Michaela has 5 more than half of the number that Taylor has. So if Taylor has 20 pencils, Michaela has 5 more than half of what Taylor has, then I'm going to first have to half what Taylor has, right? We're going to say 20, and algebraically I would write it as 20 over 2, which means the same thing as 20 divided by 2. And then she had 5 more than half of what Taylor had. So this is how we would write it for Michaela. Okay? Michaela has 20 divided by 2 plus 5 more. Okay? And so if I were to ask you to write an expression to tell me how many pencils Michaela has, we could leave it at this. We could leave it as 20 divided by 2 plus 5. That is a numeric expression. Okay? If I wanted, I could take out that 20, and we could say that this is represented by, let's do P as our variable, and then we have Taylor has P pencils, Michaela has P divided by 2 plus 5 more. Okay, so again, very similar to something on the test. I hope that all helps to make sense. And that is an algebraic expression written most efficiently. Now, don't forget, I would definitely accept this. P divided by 2 plus 5. What I do need to see, though, is I do like to see the parentheses around that, because although we're working with PEMDAS, we know that multiplication or division will come before addition, subtraction. But we still want to kind of separate and keep things nice and neat. Okay? All right. Best of luck.